All right, cool. Welcome back to Mr. Trickard's revision for Year 10 Chemistry. Right now I'm going to go through acid-base reactions, what the general equation is, and how to write out a fully balanced chemical equation when we have an acid that's joined to a base. So the first thing you're going to look at, bases have a hydroxide attached to them. I like to think of it as, oh, there's a base. OH, as soon as you see that, it is a base. Acid, they'll tell you it is an acid. Hydrochloric acid, sulfuric acid, nitric acid, all of them. First thing you're going to do is write out your reactants. So in this case, we have hydrochloric acid and sodium hydroxide. So we get hydrochloric acid added to sodium hydroxide. Make sure that it is correctly balanced with the charges. In this case, it already gives us the charges. Reacts to produce, we know that an acid and a base produces a salty H2O. So we have some sort of salt, and we know that water is formed. Now the salt must be made up of whatever hasn't been used already in our reactant side. So in this case, we've used the OH and the H to form H2O, which leaves sodium and chloride left. We write the metal and then the non-metal first, so it must be sodium chloride. Now, what you're going to do is just to double check that your charges are balanced, go to your periodic table, go to your ion sheet, which should be at the back of it, double check sodium has a charge of +1, chloride has a charge of -1. So they are already balanced. I do not need to swap and drop anything. NaCl is the written equation. What I now have to do is double check and see that everything is balanced either side of the equation. I'm going to go check hydrogens. How many do I have this side? I've got 2 hydrogens, 1 sodium, 1 chloride, and 1 oxygen. On this side here, 2 hydrogens, 1 oxygen, 1 sodium, and 1 chloride. So in this case, it's already balanced. Sometimes you will see that they are not balanced, and this one is a little bit trickier. We have sulfuric acid and potassium hydroxide added together. Okay, so let's write these. KOH and H2SO4. I see that potassium hydroxide has that OH, so O, it's a base, plus H2SO4 with my sulfuric acid will produce water and a salt. Okay, what my salt is, I've used my H's here, and I've used my H's here, and my OH. So I'm left with KSO4. So I'm going to write KSO4, but now I need to double check that my states, that my charges are balanced. So I'm going to go and look at my data booklet. I'm going to find what my charge for potassium is. Potassium is 1. SO4 is a sulfate. It's -2, so they are not balanced. So I need to balance it using the swap and drop method. K is +1, SO4 is -2. Easiest way to do this is to swap it and drop it, and swap this and drop this too. So my written equation would be K2SO4. Now I need to double check and see that my whole equation is balanced. I like to draw my line across the middle. Start by looking at how many K's do I have? I've got 1. How many oxygens do I have? I've got 1 here and 4 here, so I've got 5 total oxygens. Hydrogens, I've got 1 here and 2 here, so that's 3. And how many sulfurs? I've got 1. Now I'm going to do the same on my right-hand side, on my product side. 2 potassiums. How many oxygens? 1, 2, 3, 4, 5. Hydrogens, I've got 2. Sulfurs, I've got 1. All right. It is not balanced, so now I need to go through and balance it left side and right side. I'm going to start with my potassiums, 2 on the right, 1 on the left. Easiest way to get this 1 to a 2 is just to multiply using a coefficient at the front of my potassium hydroxide to say that I've got 2 potassium hydroxide molecules. This now means I've got 2 Ks, 2 oxygens here, so total I've got 1, 2, 3, 4, 5, 6 oxygens. 1, 2 hydrogens on this side, and there are 2 on the right side, so that's 4. And my sulfur still stays at 1. Now I've got to check my potassiums are now balanced on this side and on this side. Oxygens are almost there, 6 and 5. Ooh, this one's going to be a tricky one to balance. Hydrogens 4 and 2, S 1 and 1. 6 oxygens on the left-hand side, 5 on the right-hand side. To get this to 6, what I can do is double my water on the right-hand side. So put a 2 in front of it. That now means I've got 2 oxygens here and 4 on the right-hand side here. So this changes my oxygen total to 6. And it also means 2 H2s, which means actually 4. And just like that, the whole equation is balanced. So this will be my fully balanced chemical equation.